that they were going to have for a very long time. But fortunately for them and for all of us, it had a perfect launch and was launched in February of 2002. One of the unique aspects of EnviSat is that it is both a passive and an active system. It has the traditional passive electro-optical devices like Landsat or Spot, but it also has a very large space imaging radar on board as well. So it's slightly unusual in that it carries both active and passive systems as well. Huge satellite, again over 8,000 kilograms, a launch mass, has a very useful imaging radar as well as many different other kinds of sensors as well. The radar data has 30 megapixels, very high resolution for radar, and EnviSat is one example of a different way to do remote sensing. Instead of having many satellites, perhaps like NASA, many satellites in the same orbit following, this is where you put all your eggs in one basket and hope that everything gets up there and works. And in this case of EnviSat, it certainly did, and it has provided a wide variety of very useful data. Another system on board EnviSat is the Maris. Again, somewhat similar to AVHRR, 300 meter spatial resolution, 15 bands. Very useful for things like ocean analysis, and you can see here a beautiful image of the Pillars of Hercules, the entrance into the Mediterranean Ocean, and the different sea surface temperature within that area. Here's another lovely image from Maris, medium resolution, the entire Italian peninsula and Corsica, the islands in the Mediterranean, the beautiful image of the Alps. Again, more coarse or moderate spatial resolution, but you get a much wider swath width for that. It had many different other sensors as well, microwave radiometers, altimeters, ozone measure, all kinds of stuff. And again, the benefit of this is by putting all of these things in one bus, acquiring data at the same time, we get that contemporaneity, we get the ability to acquire many different kinds of information at the same time, and that makes all of the data even more useful to us, and more we get more out of that by having those systems operating from the same bus. Spot 5 was launched in 2002, and so they're already looking for the follow-on, the next follow-on. And the French, along with the Italians and other European organizations, are looking at how can they best follow this system on. And what they're thinking about now, this could change in the future because it's still a bit early in the planning stage, but right now the next generation follow-on system for Spot is going to be what they call Orfeo, a dual-use system, again somewhat like the next generation Landsat, where it's going to combine a military and civilian payloads. Orfeo is going to be a dual-use military and civilian system, next generation system. They're planning on spending about $360 million on this. They are planning on launching two high-resolution optical systems called Pleiades with 0.7 meter spatial resolution. That's about 2 feet spatial resolution with a 2.8 meter color stereo, 20 kilometer swath width in 2008, and also 4 individual high-resolution radar systems, 3 meter spatial resolution radar systems, again for both military and civilian purposes. So this is the thinking right now for the follow-on for Spot 5, after Spot 5, but again, we don't know exactly whether or not this system will come together as it is planned, or indeed if it will be able to be launched at this time. So that's the French and a little bit about other European remote sensing activities. A fascinating example of the use of space remote sensing, appropriate use of space remote sensing in a developing world context is India. India has perhaps one of the best, if not the best, space program in the world in terms of applying its technologies for its specific needs and requirements. India has their own launch systems, they have their own telecommunication satellite systems, and they have their own space remote sensing systems as well. In fact, they launched their first space remote sensing satellite in 1988, just 2 years after SPOT launched theirs in 1986, the IRS-1, Indian Remote Sensing Satellite number 1, a fairly Landsat comparable system, had, you can see here on the slide, 36-meter spatial resolution in the second system and 72 meters in the original, so it's roughly comparable to the Landsat MSS and thematic mapper. In 1994, they launched the next generation with 23 meters. They launched a radar system with a 25-meter spatial resolution. India has a very, very active space remote sensing program, and is very focused on meeting India's specific requirements in terms of agriculture, environment, and economic development. It's focused very much on developing technologies, not for technology's sake by itself, but developing technologies to assist India in the specific kinds of development issues that they face. Here's a beautiful image of some of the Indian data that we can see. This is a 5-meter satellite image on the right, which is the area just around Washington, D.C. You can see very clearly Washington, the rivers, the bridges across, 5-meter data, very high spatial resolution. In the left, the color image is a 5-meter data set merged together with a color Landsat 30-meter image. So we're getting the color, the spectral data, if you will, from the Landsat and the high-resolution spatial data of the Indian remote sensing satellite at 5 meters. Very high-resolution data. The Indian systems are excellent. They work extremely well. Very high-quality data. And here's a fascinating image. I actually grew up in Oklahoma City, just outside of Oklahoma City, Oklahoma, a little place called Midwest City, just outside of Tinker Air Force Base, a large U.S. Air Force base. And in fact, you can see the runways of Tinker Air Force Base here in the upper right portion of this image. In this image, you can actually see the path of the huge major tornado that struck the Oklahoma City area just a few years ago. And the path of this is this light area that you can see here. This image was taken only a couple of days after the tornado passed, in moving in this direction. And you can see the lighter area is essentially the part of the earth that was scrubbed clean of vegetation and everything else. And you can also see that this tornado was headed straight for Tinker Air Force Base, and it just turned away at the very last minute. But this is an excellent example of the kind of data that can be acquired from these satellites, and the amazing things that they can show us about our planet Earth. India has also launched a wide-angle, low spatial resolution sensor called WIFS. This is a 180-meter spatial resolution, very wide swath width, and again, here's just an example of the kind of information that we can see in this, and here's a lot of snow cover here. This image was taken in the winter over North America, and you can see the snow cover up in the northern areas, some clouds off of the Chesapeake Bay. Again, very comparable to the vegetation sensor of SPOT or the AVHRR or MODIS of the United States. India continues to develop its remote sensing technology. Very active program. They launched a research satellite in 2001 with a 1 meter spatial resolution. 2003 they launched Resource Sat that has an improved 23 spatial resolution multispectral system. 2005 saw the launch of a CartoSat, a satellite specifically to do cartographic mapping at the 1 to 50,000, 1 to 25,000 scale. 2 stereo pan imagers, somewhat comparable to SPOT, capable of generating ortho images, these digital elevation models that I showed with the SPOT data of Grenoble, and to generate high precision georeferencing for cartographic mapping products. Very advanced satellite, but also very functionally focused. It's focused on meeting needs that India has in terms of meeting its mapping requirements. OceanSat is the next one, again, oceanographic satellite, very advanced technology, and again, very focused specifically on meeting the needs of the Indian people. China and Brazil have joined together to launch 2 satellites called CBEARS, the China-Brazil Environmental Remote Sensing Satellite. In Chinese, it's called Ji1. This is a joint project between INPE, the Brazilian space agency, and the Chinese Academy of Space Technology. INPE developed the sensors and the satellite, and the Chinese launched it. 20-meter multispectral data, 5 bands, a 80-meter panchromatic and far infrared. Wide field imager, again, comparable to AVHRR or CWIFs. Both satellites launched and operated just fine, extremely well. An interesting technology transfer activity. The Chinese had the launch capability and very much wanted to gain additional capability in advanced space remote sensing systems. The Brazilians had the technology for the satellite sensor itself and more satellite bus technologies, so they joined together. Each have learned important things from the others, and it's provided very useful data for both, and also, importantly, useful learning as well. The Chinese continued to develop their remote sensing capabilities. In 2004, they launched the next generation of the Ji1 family. It's a new system, a follow-on system, different from the CBEARS. I regret I don't have a great deal of information about this. The only picture of it I could find is this pretty first release stamp showing the satellite bus. So I'm sorry, I don't know very much in terms of specifics about this second generation Chinese digital remote sensing satellite system, but we will certainly be learning more about it as we go on in the future. Again, somewhat similar to India's practical application, China is in the process of developing their own disaster mitigation and warning satellite constellation. This is a fairly new development. They are looking at establishing their own internal constellation of satellites specifically